So we're going to solve these equations using the inverse operations. Okay, so here we start with an inverse sine equals pi over 2. Now we can kind of think of what this looks like. Well, if it's pi over 2, okay, it's right there, and the inverse sine would mean I want the sine ratio of 1. Okay, so the answer, we can undo this using 1. However, we could also undo this using the inverse operation. So I'm going to write it in its inverse form. Okay, so this is the exact same equation, okay, but we can rewrite using sine. And it looks like this. Okay, so then this is equal to 1. We can actually calculate that, and that's what we get from this picture here as well. Okay, so then we can use this same picture here and say, well, what? We can undo this using arc cos, but we can undo this using just our picture here. It's probably easier because remember that arc cos has a limited domain, whereas the cosine is good for all these values. Okay, so there's my cosine equal to 1. That means that my angle, the inside part here represents the angle. Okay, the angle position that gives me that ratio of 1 is x minus pi. So that equals the angle 0. That means that pi x is equal to pi. Now, but remember that this is theta 1, and there is a theta 2 that we have to consider. But given this picture, there's no other place where we can draw cosine equal to 1. Okay, now if we had some points here, right, there's two different x coordinates here and here, that because of the symmetry of the circle. But because of the symmetry of the circle, okay, we can just say that, well, it's on the line of symmetry, so we know that there are not two possibilities here. So this represents our only solution for this problem. Okay, now, sorry, I shouldn't say the only solution, because this cosine is a repeating function. We do have to make sure that we include the repetition, so n2 pi. Okay, because we should assume that this is being solved for all real numbers. Okay, for this one here, we can undo the log. We're going to undo logs using an exponent. Okay, so we end up with pi to the power 1 is going to be equal to the arc cos of x minus 1/2. Okay, and so we can undo the arc cos using, we can look at what is the arc cos, what angle gives us that value pi, or sorry, what cosine ratio, sorry, I should reword that, the cosine ratio x minus 1/2, remember that this is a ratio, is going to give us the angle pi. So the angle pi is right here, the ratio is going to be -1. We could also write it this way, again, just like we did up here. To undo the arc sine, we use sine. So I can undo this cosine using its inverse cosine. You can write it using the cosine function. So cosine of pi must be equal to x minus 1/2. Okay, so then we get that's equal to -1. Okay, and our picture kind of gave us the same idea. So cosine pi is equal to x minus 2, sorry, 1/2. Okay, and then we can solve for x. X works out to be, add 1/2 to both sides, we get -1/2. Now in this case, because we're not solving the cos, here we solved cosine. Okay, so we're undoing cosine. Cosine has multiple solutions. Here we are solving for arc cosine. Arc cosine only has one solution. Okay, because remember the arc cosine is going to be in a limited domain. So the arc cosine, the domain of arc cosine is not the whole circle and all its repetitions. The arc cosine is only those angles in there, so that when we solve that, we only get -1. Okay, so what about solving using a table? Okay, using a table of values. So here we have we can unsolve this equation, but we have an f of x, which we have no idea what the actual calculation for f of x is. All we have is the input and output of f of x. Well, how do I do that? Well, let's start with undoing these parts here. I've got a minus 3, so I'm going to undo that minus 3. I'm going to undo the minus 3 with a plus 3. Okay, I'm going to undo the log with an exponent. Okay, so now at this point, I have to undo the f of x. Okay, well the f of x is equal to 8. How do I undo this? I need the inverse operation. I don't have the inverse operation, but I have the input and output. Well, I know my output is 8. That's my f of x value. If I want to do the inverse, I want to know the input. I'm going backwards through my function, and that's undoing the function. So if my output is 8, my input was 4, well, x minus 8 represents x squared minus 8 represents my input. So my input of x minus 8 must be equal to the input of 4. Okay, so if I input 4, I'm going to get an output of 8. So this input must have been equal to 4. And I can undo or solve equations based on the table like this. So once I've done that step, then I can just do the rest. X squared equals 12, and then x is equal to undoing the square. I get plus minus square root of 12. So there's my solution.